After years of careful planning and international teamwork, Britain is on the brink of unveiling its most ambitious fighter yet, the Tempest. This sleek, sixth-generation jet combines stealthy contours, raw engine power, and intelligent AI to redefine what a warplane can do. Built in partnership with experts from Italy, Sweden, and Japan, the Tempest promises surprises in weapons delivery, pilot support, and unmanned wingmen. What hidden features lie beneath its smooth surface, and how will it change the face of aerial combat? Join us as we explore the capabilities of the new Tempest 6th-generation fighter jet, which was recently launched to replace the Typhoon. These days, the race to build a 6th-generation fighter jet is on in full force. Big military powers want the smartest, stealthiest planes to stay ahead of future threats. While the United States has long set the pace with jets like the F-22 Raptor and F-35 Lightning II, other nations are pushing forward too. China's J-20 is already flying patrols, and Russia's Su-57 prototype has shown off its stealthy moves. Now Britain isn't sitting on the sidelines. Its Tempest project aims to match or beat the best of these rivals. With cutting-edge engines, AI co-pilots, and secretive new weapons, the Tempest could shake up the skies and prove that the UK still knows how to lead in fighter jet innovation. The name Tempest carries a proud British legacy. Back in World War II, the Hawker Tempest was built to take on Nazi fighters, stepping in for the older Hawker Typhoon and helping turn the tide in Europe. Today, Britain is ready to retire the modern Typhoon and bring the Tempest name back, this time for a cutting-edge, 6th-generation jet. This project began not long after Brexit. With the UK leaving the European Union, France stood alone in the EU as a nuclear power and aerospace leader. The UK, eager to support its defense industry and create high-tech jobs, launched its fighter program. The goal was to build a strong, modern aircraft to defend the country for decades. After Brexit, Britain felt a strong need to boost its own industries, train skilled workers, and strengthen its economy. To answer this call, the government decided in its 2015 Strategic Defense Review to start a brand new fighter jet project. This plan, called the Future Air Combat System Technology Initiative, set out to build the skills and technologies needed to eventually take over from the aging Eurofighter Typhoon and expand the capabilities of the Royal Air Force. One of the first moves came in 2017 when the UK teamed up with Japan to form a joint working group on fighter development. Just a few months later, in February 2018, the then Defense Secretary Gavin Williamson said the ministry would craft a fresh strategy for combat aviation. By the summer's Farnborough International Air Show in July 2018, Williamson pulled back the curtain on the new jet, Tempest, revealing a life-size model. The aircraft had sleek, triangular wings called delta wings and two vertical tail fins angled outward, giving it a stealthy profile. Right from the announcement, a strong team was in place. BAE Systems was chosen to manage the overall project, while its sister company, MBDA, would focus on the weapons. Leonardo UK signed on to develop the sensors, electronics, and flight control systems. Rolls-Royce took responsibility for designing the next-generation engine. To get the work done, the government promised over $2.6 billion in funding to see the aircraft from concept through to at least 2025. Looking at the Tempest mock-up, one might not find anything wildly different from other modern fighters at first glance. But under the skin, it's built with a plug-and-play design. Each mission might need a different mix of sensors, weapons, or fuel tanks, so engineers created standardized bays and attachment points. This modular setup means parts can be swapped out, upgraded, or replaced as new technology emerges, giving Tempest a long, flexible service life without complete rebuilds. Another cutting-edge idea comes straight from advanced manufacturing. BAE Systems plans to make around 30% of Tempest's structure using 3D printing. By building components layer by layer from metal powders, they can craft complex shapes that would be hard or impossible to mill from a solid block. The process is faster, reduces waste, and can even let designers tweak a part's internal lattice to balance strength against weight. All these steps, forming the international team, locking in billions of dollars of funding, and tapping modern production methods, show Britain's commitment to forging a fighter that stays on the front lines of technology. The Tempest isn't just another jet on the drawing board, It's a flexible platform meant to grow and change with mission demands and technical advances. By investing early in modular designs and 3D printed parts, the UK aims to keep the aircraft ahead of rivals for decades to come, ensuring the RAF remains ready for future challenges. The fighter features a subtly raised rear fuselage that makes room for smooth, S-shaped air ducts tucked behind its twin-engine inlets, which are set neatly into the aircraft's body. This design hides bumps and hot spots, helping to keep radar and heat-seeking sensors from locking onto the jet. By smoothing its shape and tucking away heat sources, the Tempest cuts down on the shadow it casts on enemy screens, making it much harder to spot. Like most stealth aircraft, the Tempest will carry all its fuel and weapons inside its hull rather than on external pylons. This choice preserves its sleek outline and further reduces its radar signature, but it also adds to the jet's empty weight. Engineers believe the best compromise is a weight somewhere between today's Eurofighter Typhoon and the US F-22 Raptor. Even though hiding fuel and armaments internally tax on extra pounds, the designers plan to balance that out with very powerful engines that can handle the load without sacrificing speed or agility. A vast amount of electrical power will be needed on board to run advanced sensors, cool sensitive electronics, drive weapon systems, and keep the aircraft's hot spots from standing out on infrared cameras. Rolls-Royce is developing engines that can meet these demands by combining a high thrust-to-weight ratio with the ability to run at very high temperatures. Making more thrust per pound of engine weight gives the fighter strong acceleration and helps it carry heavy internal systems. Operating at higher temperatures makes the engines more fuel efficient, so the jet can stay in the air longer or carry extra stores without burning through its tanks too quickly. Efficient power and thermal management systems will steer electricity to where it's needed most and prevent critical components from overheating. Rolls-Royce engineers aim to generate about 1 megawatt of onboard electric power, 10 times the output of current Typhoon engines. Achieving that goal would let the Tempest support powerful radar, electronic warfare gear, and cooling equipment needed to mask its heat signature. To reach this level, the company is building an embedded starter generator directly into the engine core instead of relying on an external gearbox and generator. Early tests began in 2014 when a starter generator was fitted inside an existing jet engine, and by 2014, teams had added energy storage and controls to manage power flow. The next steps will introduce more efficient power loops, smarter temperature control, and storage systems tuned to how the fighter actually flies. Because stealth jets often stand out on infrared scans, having the engines double as a cooling system is vital. The gas turbine won't just produce thrust, it will act as a high-temperature power plant and cooler, with smart controls that shift engine output between making thrust, powering onboard electronics, and running heat exchangers to bleed away hotspots. This integrated approach means the Tempest can hide its heat signature more effectively than earlier fighters. By combining a gently bulged rear fuselage with hidden air ducts, internal fuel and weapon bays, and Rolls-Royce's powerful, cleverly managed engines, the Tempest promises to be both hard to detect and hard to stop. As these technologies come together, the new British fighter will push stealth, speed, and onboard power beyond the limits of today's warplanes, setting a high bar for future air combat. Rolls-Royce recognized that modern and future fighter jets would need far more electrical power than what current engines can offer. To meet this challenge, they began work in 2014 on the Embedded Starter Generator program, dubbed E2SG. Traditional jet engines drive their electrical systems by using a gearbox attached to the engine's main shaft, which powers a separate generator. This adds weight, complexity, and points of possible failure. The E2SG approach places an electric starter generator directly inside the engine core. That way, the same unit can spin the engine up for startup and then deliver electricity to every part of the aircraft during normal flight. By doing this, Rolls-Royce aimed to remove the bulky external gearbox, save space, and make engine builds simpler and more reliable. In the first development phase, engineers fitted a starter generator inside a production fighter engine center. By integrating the electric motor generator right onto the engine shaft, they showed that they could start the engine and build power without needing the old gearbox setup. Having fewer moving parts means less maintenance and a lower chance that something will break when crews are far from home. After laying down that foundation, they moved to the second phase in 2017. In this step, they hooked the generator to another section of the turbine and added an energy storage system similar to a small onboard battery. They also wrote new software to control how power moved between the engine, the stored energy, and the aircraft's electronics. This allowed the system to juggle electricity demands during high-power events, like firing up sensors or running cooling for stealth coatings. Every time electricity was needed, the system could draw from both the generator and the storage bank, keeping all systems powered smoothly. The third phase, which kicked off around 2020, has engineers pushing the design even further. Rolls-Royce plans to create 2 separate electric loops inside the engine to deliver even more power, almost like having a backup generator ready to kick in when needed. They also aim to upgrade the engine's thermal controls by fitting advanced heat exchangers and materials that soak up or release heat in tune with how the engine heats up and cools down during different flight conditions. All of these upgrades will tie into a central power management brain that constantly adjusts engine speed, power output, and heat flow. That way, the engine can feed laser weapons or run dozens of sensors at once without shorting out or overheating, while still keeping weight and size in check. At the same time, Leonardo UK is busy building the electronics that will turn all that power into actionable information in the Tempest fighter. Their work covers 4 major areas. First, they are creating new radar and electronic warfare gear that uses digital beamforming. This lets the radar look at many targets at once or focus tightly on one, all without slowing down. They are also developing a wideband radio frequency sensor that switches between modes to hunt for different threats, from other jets to ground radar emitters. Second, they plan integrated sensing, where data from radar, infrared cameras, electronic listening devices, and even offboard sources like drones all feed into a single processing unit. Third, they will use augmented and virtual reality overlays in the pilot's helmet or cockpit screens. Flight paths, targeting markers, and system warnings will appear right in the pilot's view. Finally, an AI-driven co-pilot will help with quick decision-making. It can react faster than a human to sudden threats, and if a pilot blackouts from high G-forces, the AI can take over instantly to keep the aircraft on course. By combining Rolls-Royce's groundbreaking power plant technology with Leonardo's sophisticated avionics, the Tempest project promises to deliver a truly next-generation fighter. Its engines will produce enough electricity for high-energy weapons, active cooling, and advanced sensors, all from a lighter, simpler package. Inside the cockpit, pilots will feel like they are one step ahead of the fight, with AI support watching their backs. This blend of power, smart electronics, and artificial intelligence aims to keep the United Kingdom's Air Force at the front of air combat for decades to come. Since the Tempest's main mission over the coming decades will be to secure control of the air, it will need both strong firepower and smart, flexible support systems. One of the most talked about ideas is fitting the Tempest with a heavy punch of missiles, perhaps between 6 and 8 of them, housed inside its sleek body to keep its outer shape clean and stealthy. So far, though, no official figures have been released on exactly how many missiles the Tempest will carry. By comparison, in regular service with the Royal Air Force, today's Eurofighter Typhoon typically loads 4 to 6 long-range, beyond visual range missiles, plus 2 to 4 shorter-range, infrared-guided missiles. It also carries an internal 27mm Mauser cannon with about 150 rounds and can be fitted with up to 3 264-gallon fuel tanks for longer flights. Looking ahead, the Tempest is likely to be armed with next-generation weapons that combine the best of British and foreign technology. One of those is the JAM missile, a joint effort between the UK and Japan. This weapon stitches together Mitsubishi Electric's Advanced Active Seeker, essentially the missile's eye, with MBDA's Meteor air-to-air missile motor, which uses a ramjet engine for sustained speed and range. The result should be a fast, agile missile that can home in on enemy aircraft over great distances. Beyond air-to-air combat, the Tempest might also carry new kinds of cruise missiles, aimed at taking out ships or other high-value targets on the ground. These would eventually replace the Storm Shadow, Scalp family of air-launched cruise missiles currently used by Britain and France. Modern cruise missiles can fly low to the sea surface or terrain, avoiding radar detection, and strike from hundreds of miles away. Perfect for first strike missions or hitting targets that are heavily defended. But perhaps the most futuristic idea is that of loyal wingman drones flying alongside the Tempest. In small groups or swarms, these unmanned aircraft could undertake dangerous tasks that would be too risky for a pilot. They might scout ahead, jam enemy radar, launch their own missiles, or even draw enemy fire, protecting the human-piloted jet. With every new generation of fighter jets becoming more complex and costly, adding cheaper, expendable drones into the mix could give commanders more options while reducing risk to personnel. To speed up development and share the burden of research and production, the UK government has brought in a host of partners from around the world. At the Farnborough Virtual Air Show in 2020, then Defense Secretary Ben Wallace announced that 7 more companies would join the existing core team, now called the Tempest Consortium. These newcomers included GE UK, a joint venture of General Electric and UK interests, GKN, Collins Aerospace, Martin Baker, Kinetic, specialists in weapon systems, Spirit Aerosystems, airframe builders, and Thales UK, sensors and electronics. Together, this expanded group is tasked with designing, testing, and proving more than 60 separate technology ideas for the future fighter. That work ranges from new engine components and stealth-friendly airframes to advanced cockpit displays and AI-driven control systems. Each company brings a different piece of the puzzle, and by sharing the load, the UK hopes to keep costs manageable and get cutting-edge capabilities into service more quickly. All of these developments, advanced missiles, partner-built drones, cutting-edge cruise weapons, and a strong multinational team, are being aimed at one clear goal: making sure the Tempest and its networked wingmen can dominate the skies well into the 2030s and beyond. By blending proven British know-how with fresh ideas and international collaboration, the UK wants to field a fighter force that is stealthy, powerful, and smart enough to meet whatever challenges the future might bring. In December 2020, the United Kingdom formalized its Tempest partnership with Italy and Sweden by signing a memorandum of understanding that outlined each nation's contributions in technology, funding, and expertise. Not long afterwards, Japan joined the effort, committing to co-develop an engine test bed and a demonstration radar system, codenamed Jaguar, specifically tailored for a 6th-generation fighter. The engine test bed will allow engineers to simulate extreme conditions on the ground, ensuring the power plant meets the demands of a stealthy, high-speed aircraft. Jaguar aims to prove advanced, power-efficient radar modes that can swiftly switch between searching, tracking, and electronic warfare before being integrated into the flight-ready Tempest. Developing a cutting-edge fighter is a costly endeavor. From initial design through to full-scale production, the UK expects to spend more than $8.3 billion on the Tempest program. By comparison, the US Air Force's estimate to research, develop, and manufacture its new B-21 Raider stealth bomber stands at roughly $29.5 billion, about 3 times the projected cost of Britain's next-generation jet. Despite this hefty price tag, British defense officials have emphasized speed and efficiency, announcing in July 2022 that the first flying prototype should take to the skies by 2027. Thousands of engineers and technicians at BAE Systems in Preston, England, have already begun assembling and testing parts for this prototype, with early flight trials set to reveal key data on aerodynamics, stealth coatings, engine performance, and avionics long before full production ramps up. Looking ahead, the goal is to have the Tempest fully accepted into Royal Air Force service by around 2035. That timeline gives the RAF ample time to train pilots, develop new tactics, upgrade maintenance facilities, and build the supporting infrastructure needed for a fighter equipped with stealth features, powerful sensors, AI-driven systems, and tightly integrated unmanned wingman drones. By sharing the development burden with Italy, Sweden, and Japan, the UK can tap into specialized skills such as advanced materials from Italy, cutting-edge radar work from Sweden, and engine expertise from Japan, while keeping overall costs more manageable. In doing so, Britain aims not just to keep pace with other air power superpowers, but to take a leading role in fielding a networked, competent air combat force that will dominate the skies well into the 2030s and beyond. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.